Professor Wes Schilling, Professor of Meat Science, Sensory Science and Food Chemistry at Mississippi State University at the Department of Food Science, Nutrition and Health Promotion. So Professor Schilling serves as the undergraduate advisor for food science. He has developed 5 courses at Mississippi State University that focus on hands-on experiences and real-world examples that he has experienced through interaction with food companies. That's very interesting. I could learn from that. Wes. Real-world examples are related to topics taught through food chemistry, instrumental analysis and sensory testing principles. His research focused on sensory science, meat processing, and that includes poultry, beef, pork, and catfish, meat quality, flavor chemistry, and statistical methods. Statistics is very important, so that's very good. You have published more than 100 peer-reviewed papers in various journals. You have written more than 30 invited articles for trade magazines such as Meeting Place and Kinetic, and completed a sabbatical in 2012 in Johnsonville Sausage. I guess that is a meat producing company. Yeah. Which helped him learn to better design research projects to impact business decisions. And the title of your lecture is Sensory Evaluation and Shelf Life Analysis of Muscle Food Products. Please, Wes.
Thank you, Dr. Carlson. Can you hear me? Yeah. Sound good? Okay. Well, first of all, I just want to say what a pleasure it is to be here. I'm going to try to say it right, but thank you to the Butterbow Foundation. Was that close?
That was yours.
Okay, excellent. And I really, it's been great to meet Dr. Tornberg and Dr. Carlson. I've known their names for years, but never had the opportunity to meet them. And Dr. Zhang, I'm going to tell a little story on him, but I wouldn't be here if it wasn't for him, so I appreciate that opportunity. And 15 years ago, I was a graduate student. You know, we all were at one point. And I think Yuling reviewed one of my journal papers. And he was nice enough at a conference to sit down and talk to me about it and talk about mechanisms and how important it is to try to explore the mechanisms when in a discussion when you're talking about your research on a paper. And so Yuling is a great guy. He takes time for young scientists and helps to mentor them. So I just wanted to share that story. And he didn't know I was going to say that. Or I don't even know if he remembers it. Okay, well, I'm the last talk, so everybody say yay. But I'm going to talk about sensory evaluation and shelf life. I am Mississippi State University. Here, I just want to show you a picture of my lab group. So this is my lab group. Or you can also say that one of them is natural, but I don't know which one it is, and you can let me know because we all have different definitions. All right, so I'm going to talk a little bit about ingredient or additive substitutions as far as some different food products that we've worked with. So pork sausage, and this is fresh pork sausage, because in fresh pork sausage they put BHA and BHT in the sausage. So what kind of testing can you do from a sensory perspective would you add those natural antioxidants? Cooked marinated chicken. Most of the poultry companies in the U.S. now are trying to not put phosphates in their cooked marinated chicken, and it's hard. It's very difficult. So we'll talk about that. From Mississippi, well, actually I'm not from Mississippi, but I've been there 13 years and I worked there. But they're the biggest catfish producing state in the United States, so got to talk about catfish. And then talk about carbon dioxide packaging of chicken parts and shelf life testing there. So these are the tests that I'm going to talk about. I'm going to talk sensory difference testing as far as pork sausage goes. Because when you add those antioxidants, you want it to perform the same way that it did with the BHA and BHT. And just because those are natural, if it doesn't perform the same way, then your customers aren't going to buy it because they like it how it is. And then get into consumer testing with both catfish and pork sausage example. And some of the examples I'm going to give you are statistical in nature. So I'm going to talk a lot about statistics, so just nod your head if you're not real excited about the statistics, but I'm going to talk about it. Then I'm going to talk about shelf life testing. because pork sausage, fresh pork sausage in the refrigerated section of the grocery store lasts about 14 to 21 days. But if you add different antioxidants other than the BHA and BHT, how long is it going to last? And how's that going to impact the economics of the product? And then do just a little bit about descriptive testing. And I'm going to bring in an example of cheddar cheese there just because cheddar cheese is awesome. And it's the easiest example to look at. Yeah, I learned from Ava that instead of saying awesome, I should say magic. Is that right? Okay. So first example is the fresh pork sausage. And Dr. Carlson, I talk forever too, so feel free to keep the time going. All right, so fresh pork sausage in the United States, they use pre-rigor meat because without pre-rigor meat, they're not going to have a good protein bind, so it's not going to have good texture, and it's not going to last nearly as long because it has those natural antioxidants in the meat that stay active in pre-rigor meat. 3% water, because if they put more than that in there, it's illegal. If they put less than that in there, they're not making as much money as possible. 1.8 to 2.2% salt, spice blend. Won't tell us what it is, but that's good for them. Antioxidants, generally BHA and BHT, but some are going to green tea, rosemary, cherry powder, all those types of ingredients, then antimicrobials. Now this product's frozen up to 6 months. It's sold refrigerated, so after 6 months, they'll slack it out under lights, and under 1,000 lux lights, it's going to oxidize pretty quick. Usually the first thing that's going to go wrong is it's going to turn brown. So before it has any flavor problems, people aren't going to buy it because it turns brown. And then so a lot of companies have looked at replacing BHA and BHT with those antioxidants, but they've also looked at adding those on top of the synthetic antioxidants, because if they add both of them, they're going to get more shelf life. And Ava's back there just shaking her head. Ava and I are going swimming after this, because I have never swam in a place like this. So she's going to teach a crazy American something, right, Ava? All right, so best options are for this difference testing, difference from control test. But I'm going to go over a little bit what that is. And because that our sausage, every time you make a sausage, it's not exactly the same. So it has some random variability. So if you use tests like a triangle test or an alternative forced choice test, a lot of times you're not taking into account of that variability, so you don't get as good data from that. So those are great tests, but only if your product's uniform every time, like a cooked sausage, not like a fresh sausage. That makes a little bit of sense. Now, type 1 error, these products are determined to be different when they're in fact the same. So anybody remember that from statistics? You guys having fun yet? Type 2 error, beta, products are determined to be the same when they are different. If you add an ingredient to a food product and you're going to do a test to see if it's just the same as it was without that ingredient or a different ingredient, which one of these are you interested in? What do you think? How many say this one? You guys, is anybody, you'll get out of here quicker if you participate. Type 2 error, you're interested in that because if you make a change to that product and you say that it's the same, but it's really different, and then you get it out on the market, are your customers going to be happy? They're not going to be happy. So when you do this type of testing, you really need to focus. Type 2 error, this is still important, but this is what you need to focus on. So here, example, your null hypothesis is there's no difference between pork sausage made with synthetic and natural antioxidant. So here we do this, what's called a similarity test. Keep beta constant, which is your type 2 error, not alpha. We've got 100 panelists, 36 are correct. Now we're going to go to the Excel spreadsheet because it's fun, and it's from the Melgard and other textbook. So if you have 100 respondents, 36 are correct, and you think 20% of the people should be able to tell a difference, which is your PD over there. Probability of a correct guess is 0.33. You've got an alpha of 0.32, and a beta of 0.12. What do you guys think? There is no difference because, there's no difference because the alpha is so high, and you're happy because you have a low beta. So if you have a low beta, you're happy. Now if you have 38 people, you still are happy, and you can say the products are the same because your alpha, your p-value is high, your beta is low. All right, 39 people, you're still kind of happy because your beta is at 0.05, so you can still say that there is a difference or no difference. Now here you get to 42 and you say that's a significant, that's less than 0.05, but what happens to your beta? Is it higher or lower? Higher. So what does that mean? Is that good? That's not good. That's not good at all. So because of that, when you do something like a triangle test, you got to raise your sample size so you can keep your alpha and beta low, which isn't fun. So you don't want to raise your sample size like that. So that's an issue that you can run into with a triangle test, but you need to keep track of your beta. Think about your type 2 error. I'm going to convince Ava of that before I leave for America. That's my goal. Now this is much better in a fresh pork sausage. This works great in a cooked pork sausage because it's triangle test. Now fresh pork sausage, and here we've got the difference. Now we're giving people we're giving them 3 sausages, even though there's 5 different blocks out here. We'll just ignore these 2. So we'll give them 3 products. One is a blind control, and then you've got 2 products. And you have to have a blind control because you want to know how different your control is from the control. Without that natural variability, you can't really determine how different your treatments are. So if it's a 0, it's no difference. Well, no difference is 0, slight difference 1, etc. So now, one of the most fun things I did when I was on sabbatical at Johnsonville Sausage, they had me create like power tables for that you would make that would go in the back of a textbook. It was just so much fun. Everybody else thought it was crazy, but I loved it. But anyway, so here, this is just a blip from that, and here at alpha equals 0.15, we generally use 0.05. These are what the powers are for that test with 30 samples, based on, because you have to take into account correlation and the variability of each of your treatments. Now, if I've lost any of you, you can raise your hand or you can ask a question. But here you've got your actual judges and your samples. So your p-value is 0.10. So with a normal test, would that be different or not different? Not different. Okay. But here I'm going to say it's different because at 0.15. And I'm going to use alpha equals 0.15 here if I only have 30 samples because I'm more interested in that power. I'm going to run more tests. I'm not going to go to market with a p-value of 0.10 because there's too much chance that the product, consumers would perceive it as different. Does that make any sense? You guys ready to go to dinner? Anybody? Okay, cool. All right, so take home. One of my favorite statisticians, George P. Box, he's British, he said, all models are wrong, but some are useful. So based on that, choose the best test based on your project objective. So these are 3 good options if you want to see if there's a difference when you add an ingredient. Both errors are important, but focus on beta first. Okay, cool. So that's number 1. Now we're going to go to consumer acceptability. And it's going to be awesome, I promise. Or magic. All right, so I'm going to give you my simplest case, and this is with catfish. And this is a project I actually wasn't involved with until after the student did it. It was a nutrition student, and they needed a master's thesis. But they went to the dining hall at Mississippi State University, and you got to imagine catfish. So they sell breaded catfish, they sell fried catfish, And, well, breaded baked and breaded fried. And so using a 9-point hedonic scale, they did it 3 times with 50 panelists. All right, and I just like this picture. That's what it looked like. So with 150 people, 75 would have gotten that number first, and 75 would have gotten that number first. And that would have been their score sheet. But I'm going to talk to you about cluster analysis. So actually grouping people together based on their liking scores. So here, you're grouping consumers based on product preference or degree of liking. So this can work from anywhere from 2 to 8 food products. Here it always works better with 2. You want more than 100 people, and you need to decide how many clusters do you use. So here, on that 9-point scale, and this should be 2 significant digits, but I got 3, so that's wrong. But you got 8.07 for fried and 7.6 for baked. So that tells you like very much for fried, and they still like the baked between moderately and very much, so they like it. But what does that tell you about your individual consumer? Does it tell you much? Not much at all. So we did something I love to do because it's just fun, it relaxes me. But we did cluster analysis. So here we broke down the data based on the scores they gave. So here, this is cluster 1's 10 of the panelists. What did they say for fried? They like fried. Did they like baked? No, they like that fried, good fried catfish. What about cluster 2? There's only 4 of them, but what did they think? Yeah, they want that baked catfish. All right, cluster 3, they preferred the baked, but liked both of them. 4 didn't like it as much as group 3, but they liked it, and they liked it the same. That crazy cluster 5, they gave a perfect score for the fried. They were going to give it as high as it'll go, and they got the baked. Cluster 6 is similar to 5, just lower scores. And what we called cluster 7 and cluster 8, it's not true, but it's our joke, is that these are the poor, hungry college students that came in to eat catfish, so they're just happy you gave them catfish. But that's not true, but still. All right, 57% preferred the fried, 35% preferred the baked, and 8 had no preference. So they could know, okay, both products are viable, but different percentages. All right, this is how you figure out, or at least do a rough estimate of how many clusters to use. This is called a dissimilarity plot. And this is how much dissimilarity there is with 1 cluster, or just the averages. This is with 2, 3, no, 3's here, I can't see, 4, 5, 6, 7, 8. And when it starts to go parallel, that's how you choose how many clusters you're going to use. All right. And also you can look at it from, this is a dendrogram, so this would be, this panelist is the most different from that panelist on your actual scores. And then they're grouped together based on how similar they are. And it takes out a lot of the variability of your panelists, because how many of us are in this room? About 50? How many opinions do we have? About 50. And we're all right. Yep. All right, so here, now I'm going to break into some consumer acceptability of fried catfish on another project we did. And this was fun because I had a guy from Cambodia do this project, and as far as we know, he's the first person from Cambodia to get a PhD in food science. So that was an awesome experience. But this is catfish, so just catfish, and I'll look at overall acceptability, was liked moderately. Positive control, we added salt and phosphate, because salt and phosphate make it more tender and juicy. So it improved the acceptability a little bit. Here we decided to add potassium acetate and potassium lactate, because those are going to make it last longer. This is 7 days refrigerated. This will go 10 days refrigerated. And those were liked exactly, well, on average, the same. But then we did the cluster because it's fun. And the first cluster were happy. So that's 67 of the panelists, and they were just happy you gave them any of the treatments. For some reason, group 2 did not like the high potassium lactate. There was something flavor-wise that they didn't like. Group 3, they liked all of them, but they preferred the positive control. So adding the antimicrobial knocked it off a little bit. they liked the phosphate and so forth. Group 4 didn't like catfish, or at least not our catfish. And group 5 actually preferred it with the acetate and lactate. All right, and with doing that, we also wanted to look at what's going on from the bacteria standpoint, because we're interested in shelf life. So 4 logs starting at day 0 seems kind of high, but it stayed low till it got to day 7. And our point was 7 logs there. And the controls already control and the positive control are already getting towards the end of shelf life there at day 7. But then you get to day 10 and the high potassium acetate lactate is still good, but by 14 it's gone. And these 2 samples actually smelled good because we had mostly lactic acid bacteria, not Pseudomonas, so it didn't seem that spoiled. Because this is what the actual aromas look like. How am I doing on time, Dr. Carlson? 10 minutes, okay, I'm going to skip that then. Okay, this one I like, so I'm going to talk about it. All right, this is broiler breasts that were marinated with salt and phosphate or substitutes. So here we've got just chicken, and a lot of the chicken that's produced in the United States is cooked, and then they'll chunk it and put it on pizzas or all kinds of different things like this. So this is just plain chicken, cooked, and then this is positive phosphate. Here's an oat fiber blend with vinegar, because the company that had the oat fiber blend also had the vinegar, and they loved the vinegar, so they wanted to put it in there. And then whey protein concentrate blend. So I'm just going to go over the last one, and that's the percentage of panelists that liked it slightly or greater. See, negative phosphates at 68%, 82% with the positive phosphate. And then the oat fiber blends, not as high, but it's approaching it. But where you get issues here is when you store it over time. Does it last as long? Does it have the oxidation? So it shortens your shelf life some. Okay, now I'm going to get into just a little bit of descriptive and just about right. Because for that fresh pork bratwurst I was talking about, this is a general score sheet that we would use. What does the uncooked color look like? The cooked color, pork flavor, all the way down to texture and casing texture. And here, we'll taste this out to about 18 or 19 days. It's fun to taste 18, 19-day-old sausage. And then we'll determine when it goes unacceptable, so we can determine the shelf life. Yep. So here, and this was actually that same type of pork bratwurst. I can't tell you what the treatments were because I'm not supposed to. But there's 2 treatments, and we looked at 3 different ways to determine shelf life. So we tasted it and looked at flavor, and we got a low shelf life and a high shelf life. So for the M, we had 18.2, 24 days, and this is under lights. For the S, 11.6 to 17.6. But then we also looked at total plate counts, because when it gets up to 7 logs, we say it's at the end of shelf life. Same thing with lactobacillus when it gets 7 logs. And then the redness. So usually, and you can see this, evidently this treatment makes it red because it lasted forever as far as redness, and that wasn't making it end of shelf life. But here you can see it's still 12 days, and that's all you get out of this one treatment. So what I want you to get out of this is it's important to determine all of the different ways it can go out of shelf life. So color, microbiologically, and sensory. Because in order to get that, then the shelf life, you need all of those avenues. Now here with cluster analysis of that, you can see 93% like the M, 78% like the S. But for that S treatment, a greater number of them gave greater than 7. So even though a higher percentage like that one. So, okay. And this is what we did for pork sausage as well. And most places will put rosemary in. NBHA and BHT is a standard. That's the standard thing. But here we added green tea and rosemary. So 1,500 parts per million, 100 parts per million green tea. So it showed that adding that green tea gave a few days longer shelf life. But it didn't matter how much green tea and rosemary as long as you had at least 1,500 and 100 parts per million. Okay. Oh, I like this one too. So this we actually did with prawns, and we got an ag economist to match our cluster analysis, where they looked at how willing would consumers be to pay for those products. So these were actual prawns that are kind of like freshwater shrimp, but they salt acclimated them in the water before harvesting them to try to, so salt acclimate with calcium chloride, instant ocean is like aquarium type, and then we decided, they wanted to do that, we're like, well, why don't we just marinate them? So we decided to marinate them to see what they would look like, and then we could actually match the prices, how much, they were given $20 and allowed to bid on the prawns, and whatever, they took it home if they didn't. They either took home $20 or their bid plus the remainder. Okay. Excuse me. That was loud. All right, so adding vinegar to matte packaged chicken thigh. We had a company come to us, and they're like, we're sending chicken thighs from Georgia to California, and we get 12 days shelf life. You're putting it in carbon dioxide packaging. So we put vinegar in there at 0.5% and 1% in the carbon dioxide package. You can see what the bacterial count were. And so here, by somewhere between day 12 and day 16, the control was going bad. But by day 20, with 1% vinegar, it was just about to go bad. So we could get approximately 8 days more shelf life by sending it, I don't know, how many of you have been to America? A lot of you. Have you eaten at the fried chicken restaurants? Yeah, so this is the fried chicken. Everybody in California wants to eat fried chicken, so they're sending this out there, and that's how they're doing it. All right, so skip that one. All right, so last thing I'm going to talk about, I hope. How much time I got? About 3 minutes? 3 minutes, okay. All right, so relating sensory data. So consumer testing with cluster analysis, relating it to descriptive analysis. So this is something we call preference mapping. And with the first example I'm going to give here is just descriptive, and this is with our pork sausage again. And this is principal components analysis. Ava said that we don't like principal components and multivariate in America, so I have to have at least one slide. Okay, so here, this is 0 month frozen, 3 months frozen, and 6 months frozen with different combinations of green tea and rosemary. So what we saw here is it didn't matter, and these are the same combinations I showed you with the shelf life testing. It doesn't matter as long as you've got green tea and rosemary in there for 0 and 3 months. But if you freeze for 6 months, you better have that high concentration of green tea and a pretty high concentration of rosemary as well if you're going to freeze for that long. So that's what that graph shows you. All right, so preference mapping, we're going to relate the consumer data to the descriptive data, and then we're going to map it. And so now we're getting on the cheddar cheese. And the reason I'm using this example is because it's the easiest one to explain I've ever seen. So, all right, so here we've got our cluster again, and these are cheeses aged 7, 9, and 12 months. So for cluster 1, what can you say about them? They like 9 months. Cluster 2, they prefer 9 but like 7. Cluster 3, those real cheese connoisseurs. Yeah, they like the 12 months. They actually like flavor. Somebody likes flavor. That's good. Group 4, they don't like flavor. There's not many of them, but they don't like it. Group 5's happy you gave them cheese but prefer 9 months. Group 6 happy you gave them cheese but prefer 7 months. So then we can also do descriptive and looked at the actual descriptors that match that cheese. So this doesn't mean that the 7 month cheese don't have any of those flavors. What it means is it has less in comparison to the 12 months and 9 months. And so here with the 9 months, they're much higher for cooked, creamy, buttery, sweet, and umami than either the 7 month or 12 months. And then you see those 12 months. It doesn't mean they're ridiculously high in these, but compared to the 7 and 9, they've got some more of these developed flavors. Okay, and then we can put the actual clusters on there. So now cluster 1 falls in this category, and you can see what descriptors are actually important to them as far as the cheeses go, and that goes all through, and it's got all 6 of the clusters on there. All right, now to my conclusions. So, got 2 conclusion slides. So from the first part we looked at with the difference testing, it's important to focus on beta when determining if changing to a more natural label causes a noticeable sensory difference. Cluster analysis is helpful if you want to reduce the variability in your consumer data so you can actually make more sense of it. Conclusions as far as shelf life is important when an ingredient change is made, and it needs to include, for pork sausage and a lot of meat products, sensory microbial and color testing. Then preference mapping can reveal sensory properties and intensities and help you relate it all together. All right. And this is my lab. This is really my lab group, not the minions. So that's them. And we have some undergrads. We've got some crazy Chinese grad students. We've got a crazy Indian grad student now that just started last week. And then here's our beauty star. She wasn't in the picture, so we had to get a nice picture of her. So if we want anybody to represent us in public and be a communicator, that's her. Cool. Thank you for your time. I appreciate it.
Thank you very much, Wes. Any question for Wes?
One question.
Yes, please.
I agree consumer analysis is important.
Mm-hmm.
Because eventually your product needs to get to the hand of the consumers. But the trend panel is considered even more valuable from research standpoint. I'm talking about trend panel.
It is, as long as you can relate it to what the consumer is telling you. I mean, if you just do a trained panel without ever having any touch with what the consumer thinks, I mean, we've got enough trained scientists in here to have a great trained panel, but if we're not aware of what the consumers think, it's not gonna be that helpful.
Sure, so, well, this umami, the umami, it didn't belong to any group at all. Why? Because umami is considered to be the most important.
No, it belonged to both the 9 and the 12, but it fell in between it, I think. So you've got to take those plots with a grain of salt, and you've always got to do your ANOVA first to see where the significant differences are, because if you don't, you're just kind of playing with voodoo. That's not a good term. It's not magic without the ANOVA.
Any more questions? Otherwise, I can add, when it comes to panel, I think it's very important what you discuss here, because a trade panel is like a calibrated instrument. They are looking for what you ask them to look, while a consumer panel, they are just using their experience and other things, and that's a very big difference on the results. And I don't think there is a correlation at all due to that. Thank you very much, Wes.